Hey Ben, let me know how the audio is. I haven't streamed in a long time, so I had to piece together a new OBS setup, and it's a little different. I don't know if it's good. Is there a channel over on Handmade Network? Maybe I should just drop this in the Jam channel, or is there like a live streams channel? Okay, cool. Let's see what we got. Yep. Where's the streams channel? Yeah, I might have to go do that. That must be a new feature that I haven't enabled. Hey, Jax. Yeah, it's been a while since I've streamed. I haven't been keeping a regular stream schedule because it just doesn't work for me super well right now. All right, I found the Handmade Network Discord channel. Thanks, Ben. I'm gonna post right there real quick. Okay, I think that's enough announcing it. Let's let's do some stuff. So the first thing is I need a new program. Wait, I might have let me I did a little bit of programming ahead of time before I decided this was a jam project. I did like sketch out the basic outline of a program, but it doesn't do much, I don't think. Yeah, so I've got a black window so far. Um, that's okay. Um, s- I kind of get overwhelmed when I've been rated in the past, so I'm totally okay with that. I'm happy to just chill with whoever's around. So what I've got so far, it looks like just a Scratch program. It uses the code base I use for graphic stuff. So Sets up a window, puts it in full screen somewhere, apparently. Yep, puts it in full screen, and yeah, it's just clearing to 0. So I'm going to just code direct to OpenGL. I'm not using any abstractions, it looks like. Because I haven't written any of the features, so there's no way to abstract them. Yeah, I'm just familiarizing myself with how much. I did this a couple weeks ago before I decided to jam on this thing. So all I've got, it looks like, is the very basic outline of a shader. What does it do? Okay. Do I have STB image? I do have STB image already. So I think the first thing I need to do is, yeah, do I have STB image getting used anywhere? No. Okay. So I think where I need to start is grabbing something to use as my image. I actually have the right thing already. I just need to get the full path to it. Okay. So relative to there, let me just start dropping some like configuration stuff. So the goal of this program is going to be that I want to be able to render out some videos that take input as multiple tracks. I've got some podcasts I've recorded, and I want to put them on YouTube, and I want to have an audio visualizer that I made myself. And since I have separate tracks for each speaker, I want to do the audio visualization on a per track basis so that you can see which speaker is speaking and the audio visualization kind of coordinated together. It's not an extremely ambitious visualization idea, but it half fits the theme, and it's something I needed to work on anyway. So that's what we're going to do. Configuration stuff, I need the avatar path, and let's see, that's sitting over here, looking like this. Switch those to that. Mr. Fourth podcast video render. So we'll do .. / That's the relative from the build folder. / avatars. Okay. Is that how you spell avatar? It looks wrong now that I'm looking at it. Avatar. I think that's right. I don't know. Okay, so that's the path. That's the path. Well, should I just do like full path? I don't know. I'm going to just do full path, actually, now that I look at it a second time, because I might move stuff around, and I always end up regretting relative paths sooner or later. So yeah, maybe that'll become a parameter to the program as I make it more sophisticated. But for now, let's just try to get a texture loading happening. Initializing graphics, creating a window. Somewhere in here, there must be like set up OpenGL state. Okay, where does that get called from? Right there. And it begins, okay. So I should be able to create a texture inside this region here where I have a context selected. Load avatar texture. Now I'm not going to actually want this to live here forever because I want to be able to parameterize this program on the avatars. But for now, this will be a good place to get started. And I'm going to try not to spill too much about what's in the podcast episodes I've recorded while I'm jamming for the next few days. So I'm just going to use stuff that is non-spoiler assets for now. But let's see, how do I set up a texture? first I'm gonna need to remember how to use STB image. It's like load. It wants to load from a file name if I do this one. I think that's fine. Let's just try and do it that way. Avatar path / Alan.png. Let's put the / in the path. Yep, that should concatenate those. Clayman, there's going to be a podcast. It's coming out. The first episode's coming out on Monday. This is sort of like a teaser running up to it because I wanted to make an audio visualizer for it. And I thought that it would be fun to do that on a jam stream thing. But the actual podcast announcement, like I'm spoiling the fact that there's a podcast announcement coming out on Monday by streaming right now. All right, width, height, comp. I think that means like the number of channels. Hi, thanks. I'm glad the YouTube channel is useful. The archive one, I don't feel that proud of it. It's just kind of a dumping ground. But I don't. If you tell me about what's I'd be interested to hear what's useful to you on the old channel, like the Alan Webster one, because I don't really put any effort into that. So it's a little curious to me what is valuable about it to other people. And number of 8-bit components per pixel. Okay. And then we want to put... So if I put a 4, it'll force 4. I think... the number it would have been. Okay, so... stream titles. I always forget about stream titles. Yeah. Man, that's not months old. That's like an entire, that's my streams from last year. How do you that should, okay. Let me figure out how you do this. Edit stream info. Handmade network visibility. Let's see. Multi-track audio visualizer, Handmade network jam project. All right. I can't change the fact that the email that went out was wrong, but hopefully anyone who loads the page now will see the correct thing. Yeah, what we're working on today is not x64 assembly. That was something I did a year ago. If you want to see how that went, there's archives of that stream on the archive channel on YouTube. Alan Webster, I can send that to you. But what I'm working on today is audio visualizer. All right. So that should return the data, right? So here's just our avatar buffer for now. And with this API, I have to free it, right? Avatar buff, because it's using malloc. Okay, so let me see, let me get remedy here. This is the wrong folder. Let's come over here to the podcast. Build video render. Okay. So I want to see this line right here. Oh, maybe I need to rebuild first. Get my line info correct. There we go. Width, height, Yeah, okay. So that didn't find the thing. Let me double check that I have the full path correct. Allen PNG. That should be good. Let's double check over here. Oh, I think this is wrong. Yeah, that was wrong. Let's see if that is better. Width, height, avatar buff. Okay. So that gave me a buffer with all the pixel data in it, 3 components. So let's put it in a texture. Fallback texture, avatar texture. We'll just work on one avatar first. I want to be able to support multiple avatars. We'll build up to that one little problem at a time. So first, let's get one avatar texture up and running. Gen the texture, bind the texture. We're just coding OpenGL directly, no abstractions here. Since I haven't built like a general purpose layer for RGB textures, anytime I want to do something like that, I have to do it by hand still. Let's look at the names on those parameters. Okay, so we got target, level, internal format. Those are done. Width, height, border 0. Width, height, border. Okay, format, RGB. I'm not sure if these are coming in RGB or BGR, but I guess we'll find out. Type. So this is going to be unsigned byte. And then the actual avatar buffer. Okay. So that should set up my avatar texture, but I need to also give it some parameters, and then we can throw in, I guess we can, I'll just put this at the bottom. We can throw in some error message in case it doesn't work. GL buffer data, bind texture. Autocomplete just got me on the wrong identifier there. Okay, so it ran without throwing an error, which is the only indication that that worked. Hi, welcome. We're working on this audio visualizer here. Yeah, do you like? I'm really surprised that anyone finds the archive channel interesting. I feel like I would find it boring. Hi, welcome. Thanks for the kind words. I'm planning on, what kind of stuff do you work on if it's not, game and graphic stuff? I'm curious what people watch me do. I'm gonna get into some other new stuff sometime soon. Oh yeah, okay. The lecture series on the Alan Webster channel is the Alan Webster series is pretty interesting, I think. Or not the, sorry, I'm reading chat and talking. The 4Coder lecture stuff was kind of interesting. Hi, Andrew. Yeah, I don't stream on a regular basis. This is only on special occasions when I have a project that it really suits it. So I think the next thing I need to do is see this texture. So let's just do, I think that this, let's just read this real quick and make sure that this shader is actually equipped to render a texture. It says it takes UV and an alpha value, I guess. Primitive shape, UV, and an alpha value. I can see why I would want that for what I'm going to do, so I'll leave it that way. I've got the view transform in there. And then I'm sending out a texture. I'm grabbing with the UV coordinates. It looks like I'm doing, okay. This was thinking that there would actually be alpha. There's not actually gonna be alpha. I'm gonna just modify this a little bit because we're gonna send down textures that are like from 3-channel like avatars that are probably not gonna have alpha. I guess, yeah. I'm just gonna assume they're solid. No transparency in the input avatars. All right, I see that the chat is going. I'll catch up with you guys in a minute, but I got to make some progress, and then I'll catch up with chat. Hopefully that sounds good. So let's just do a quick call. I have a helper call for drawing, right? Draw geometry, takes a texture, so that should be able to do it. Let's test out this little helper function that I have sitting here. It needs the vertices, so I guess I'm gonna have to build the triangles myself. And I've got the avatar texture here. There's 6 of them, and I need the window dim. Yep, I have that sitting around. It wants the window dim in floating point, and I have it in float up here. So let's just do a quick conversion. To window dim, expand V2 expand, is that it? Yeah. Window dim S32. Hopefully that can give me my window dim in signed. Yep, okay. So now I just need to fill out these vertices. So what's in my vertex type? We need a center point, so let's pick a center point. We'll take window dim times 0.5 to get that. And then, I need the avatar's like original size. So I guess while I'm at it, I'll just start doing this. This is probably gonna have to turn into a struct so that I can do it for each avatar separately. Width equals height, blah, 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 blah. And so if this all works, then the avatar width can come from there and the avatar height can come from there. So then what I also want is a part of the configuration. That's the size. Oh, you know what? Sooner or later, I'm gonna have to deal with the textures getting resized, or I might just resize the avatars manually to a standard size. But if I do the second option, that lets me avoid having to like mip map or resample my input textures. But it means that I can never tweak this as like a fluid ongoing parameter, right? Like I can't sit here and iterate 100 times until I find the radius or the width and height that matches whatever look I'm going for. I have to kind of just take a stab at it and stick with it. Because I have to then manually transform the data ahead of time that I'm going to send in, right? I have to use some kind of, there's an STB image resize. That's what we could do. Maybe we can use the STB image resizer first. So we'll grab the buffers, see what size they are, have configuration for the size of the avatar, use that to adjust the buffer before we make a texture out of it, rather than making a texture out of it and then trying to figure out how to sample or mip map that. We'll stick with normal, texturing, but we'll use a software side solution to rescale the image first. That's what I think we'll do. All right, I'm gonna catch up with chat real quick. Yeah, you know what? I used to like putting programming streams on. I think that's something that like after a little while I decided it wasn't my favorite kind of content anymore. But I guess I can remember a time where that definitely worked for me, where I could put someone on in the background who's doing programming stuff, and just kind of like vaguely pick up things like there's like stuff sprinkled throughout there that's interesting to catch, and you kind of can. I often need something as background noise. Well, it used to be the case that having someone talking in the background was good for me, but it has become less and less helpful. I now need like music with no lyrics is the only thing I can really work to anymore. So I could understand though if putting it in the background works for you. All right, here's a question. Hey, a while back you mentioned you were going to rewrite 4Coder since you learned a lot from making it the first time around. You still planning on making another text editor? Yeah, I am. I'm not rushing into it because I have other stuff that I feel is more important. And when I do it, it's going to be not necessarily for the same reasons I did 4Coder. So with 4Coder, I was looking for a cool project to work on. I was looking to actually gain users who would be interested in the project, and I was interested in experimenting with what could be done in a text editor to improve productivity. If I do it again, I'm going to be more interested in integrating it with a number of other tools that I want to make that I don't want to talk about too much yet because it's all kind of in my head and theoretical. So I do want to get to it. It's a part of a bigger project in my head now. Andrew says that I helped him out a lot with the Win32 demo he's working on, and now he's just trying to figure out Wasapi. I haven't done very much with the Windows output, audio output stuff, so good luck with that. I hope it works out for you. Yung Lane asks, will you write your own fast Fourier transform? I don't think I'm going to go that route. So fast Fourier transform is something I do want to write someday, and it would kind of apply to this sort of work. I'm going to use the same sort of technique that's in libquincy. In fact, if libquincy was out, I would probably just use that because I wasn't really looking to write my own audio processing thing. But I'm going to make something kind of like what that does, although I haven't seen the code for libquincy. I'm sure it's more carefully written, and what I'm going to do is going to be a sort of sloppy approximation of the same idea. But the idea is basically to use a band pass filter on several different bands in order to measure the activity at different frequencies, and then use that to create the audio visualizer. Okay, let's fill out these vertices. All right, I need like a rectangle here. So why don't we just do like top left? Yeah, I'm gonna do everything in kind of like the absolutely most top left, bottom left, top right, bottom right. Just the absolutely most least thinky, clever way and most sloppy way, just because that's going to make it easier to keep moving while I'm switching back and forth with chatting with everyone. And this thing does not need to be particularly clean. It's a jam project after all. So let's see, I was going to add into the configuration like the avatar display radius or something like that. So let's say I want a radius of 50 pixels for now. Right, so then this can become, top left would be -x, +y. Bottom left would be negative x, negative y. By the way, I'm doing bottom up coordinates, which is pretty unusual, so that's why up is positive in this particular like setup right now. So positive, 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 negative. Okay. So vertex 0 is there. Let's just be, whoops. Let's just be lazy on the UVs for a second. We'll get that more precise later. And with the alpha, we'll just go with 1.0. All right, 1, 2. So top left, bottom left, top right. 1, 2, bottom left, top left. Top left is 0, 1. Bottom left is 0, 0. Top right is 1, 1. And then we want those two again, 3, 4, 3, 4, 3, 4. Yeah, we'll definitely clean all this up so that I can make it more usable, but we're not there yet. 1, 0. Top left, top right, no, bottom right, bottom right. Yeah, so there's the vertices, there's the call. That's not good. That's not what it's supposed to look like. Let's get rid of this. Probably need one of these. Goodbye. There we go. All right, so what was that all about? Can I look at it here? So here it's not exception thrown. Can you show me where we are? Like where is the... Okay, at least the debugger lets me kill it. Let's get forecoder back up. Rebuild. Oh, whoops, no, I'm on the... Gotta pop over here to the special side project thing. Rebuild. Yeah, so that's hitting an issue, but why is it not showing me where? It's got to be like in this part somewhere, right? That we just wrote. So it gets that far, builds the vertices, goes to draw the geometry, sends down the array, and that's where it crashes. Okay. Why is that an issue? What am I missing? Reading location 0. That's weird. It's not that. It's not that. Bind texture text. It's not that. And yet, as soon as it runs this line, exception thrown, and it can't show me a call stack, but it's reading a null pointer. What on earth? Okay. Let's back up here. Okay, so that's fine. It's crashing when I send actual vertex data count times size of star v. Okay, so that sets the buffer data. That should be right. It's a dumb name for a program. Anyway, what is the deal? So size of star v vertex, I did fill that out. Verts 0, 1. I guess these are uninitialized. 3, 4, 5. It doesn't seem like that should be that big of a deal, though. Is there anything I'm forgetting to initialize? P, U, V, A. It doesn't make any sense. Reading location 0. Why? Or like, are there lies in here? 2, 2, 1. A, U, V, P. That's all correct. I'm stumped. I'm stumped already. This is super odd. What am I missing? When that's a 0. Oh, this is the number of triangles right here, isn't it? Right? Is that how that works? Nah, but that's not doing number of triangles. Here, count times 6. That's the number. No, that's the number of elements in the array. Count times 6. V is count times 6. Yeah. I mean, these all appear to be saying the same thing as what I'm doing, which is I GeoDraw arrays with a count that matches the number that I sent here. I don't think it would, Ben. I'm a little stumped why I'm getting I'm getting a thing, which, another way I could sort of zoom in on this is, well, if I don't call this, I don't get the crash, right? Right, so it's just fine. It's when I do the GeoDraw arrays function, if count is non-zero, right? So if count is 0, it's fine. But if I let it say 6, we get that. And of course, I just did that without using the debugger to protect it, so I got to do this again. What are we doing here? Not sure why it's having like a weirdly hard time dealing with that crash, right? I mean, it doesn't usually crash that hard. Yeah, let's double check a couple other things. Did I actually, it's a good question. Did I actually set up the buffer? Yeah, I have a vertex buffer set up. Buffer data should be fine to set. Size of star v. That's the handle. You know, one thing that might be good to look at is to see if I have any GL errors here. All right, what do we got? Yeah, we have an error. So now we're going to try to figure out when we're getting an error. And we'll do that by just being aggressive. Yep. Just all of them. Just all of them. Just everywhere. Don't trust it. I don't trust it. It could be anywhere. There we go. So somewhere between here and here. See, this is why you spam it everywhere, because it could be anywhere. What am I doing here that's wrong? Right here, no problem. Here, problem. Attrib, that's the issue. Got it. Okay, we want no I pointer, just pointer. These aren't integer attributes. So I need to add in that, like, yes, extra parameter for the floats. Okay. I don't know what that was about. I don't know why that was causing super hard crashes. But it was. We're good now. Yeah, it doesn't make a lot of sense why that would crash so hard. I guess it's just undefined behavior, and I don't know. I'm pretty sure in this case, the big fox, the issue isn't that I have dumps being generated or anything like that. I think it was because the crash was happening inside the driver, probably, because that would explain a couple of the things we were seeing that were weird, like the fact that the debugger wasn't showing me where the crash was, and that it was like taking a weirdly long time to close the window after the crash, even though I had like end tasked it. So like it was sort of carefully recovering from a more severe crash from the wrong sort of privilege level, you know? So we're part of the way there, but we're not seeing the texture, which we actually should be seeing. So a couple of things. One, I want to look at the buffer before I send it as a texture. My UV coordinates could just be garbage. Or let me check the geometry first, and then I'll check the buffer second. That seems like a useful way to bisect the problem. I suspect we'll just narrow it down to the fact that something is wrong inside, but I want to check these more easy to check things first. Okay. Okay, so 910590. So up, down 100, to the right 100, that again, and then to the right and down. So that should give me the two triangles that I was expecting. I'm going to pop over here to the shader code. Let's see here. And could it be that yeah, it could be something like that. Let's just ask for a little, confirmation. Failed to locate uniforms. It's really annoying issue where if it optimizes out the uniforms, then it stops, like, okay, so I'm not seeing anything there. Hi, yeah, I am Alan. That's right. Welcome. All right, so weirdly, I'm not seeing what I thought I would see, which is I thought I would see, the magenta square in the middle of the screen. Not sure what I'm doing wrong there. Nothing. I'm getting nothing back. So P goes to 0, right? P 0, 0. It's 2 floating points, yeah. UVX, yeah, is this coming through correctly? Wait. View X form, is that not coming through correctly? Or no, it would just be the texture that's busted, right? Let's just see if I run to, yeah, I did create 4coder, that's right. If I run to the spot where it's grabbing the uniforms, what do we see? Vert u view x form. So that one is still coming through. Vert u text. That's the -1. And so that's going to do that. Okay. So this should be fine though. I'll just say like, don't even bother grabbing the texture for now. Well, no, that's going to cause an issue. We want the -1 because even though, maybe what I need to do is say, we can still, let's just try something here. What if I didn't test this? If I only tested those, then that would just mean, hey, this got optimized out, but the -1 actually flows through safely. Let's just try it. Yeah, okay, that's what I should do. If I test for the -1s there, then I am treating something like an error that was actually going to fail silently and safely. Okay, so now the big question is, why am I not getting any obvious indication of the actual shape showing up? The window dim, let me double check if that's getting, I feel like the window dim should probably be coming through correctly. Yeah, that's the correct way to set. Window dim X, window dim Y. This, I'm not gonna play it. I mean, maybe someday. I don't think I'll do it today, partly because I don't have any, it's not plugged in, and I don't feel like rearranging my setup for you. Maybe tomorrow, but I'm also like not particularly good. I don't play. I just sort of noodle around with it when I'm putting together the tracks for the YouTube channel. It's more of a creative tool than a instrument for me, if that makes sense. I mean, not that there's that's not entirely separate things, but hopefully you know what I mean. I don't perform with it, I guess is the point. Yeah, if I use message callback, that is a little easier, but that requires setting up more modern OpenGL and stuff like that. It is a more effective way to debug OpenGL, I agree. But right now, it wouldn't even catch what's going on because I'm not having an error. So I'm just not getting the data flowing through properly. The out color here should show up somewhere. Whoops, I'm sorry about that. I'm sure that was unpleasant. The out color here should be showing up somewhere on the screen, and it's not. So it's like the geometry is not getting transformed correctly or something. I hate it when this happens. Like, the only really good solution is to work all the way back to, like, fundamentals. So I guess that's what we're going to do. We're going to ignore UV and A entirely. Oops, make sure that that's just removed. Can leave those there. FUV, FU, yeah, it doesn't matter. Norm position, we're going to ignore that. And that, and then instead I'm just going to put VP there. So I pop in over here. We're going to do that for later. And just simplify this all the way down to 0, 0. Well, let's see. Let's do 0 0.5, 0 0.5. Let's put negatives on those. And then go up one. Go up the other one. Go up the first one again. Go up the second one again. And then go up on both simultaneously. That should give me... Yeah, that should be coming through. I'm not sure what's going on. Verts out. It doesn't matter. That doesn't. I should be seeing that. GL clear color. If I do this, it comes through, right? Okay, so I am like rendering to the window. At least that much is known. If I send these down this way, GL draw arrays, I grab the vertices and I put them in the buffer. I have 6 of them. I set the program. Yeah, so that's got to be right because it's giving me the correct like lookups for the shader like uniforms. So that's the right handle. That's irrelevant. This is the only part that actually matters. Geo enable vertex. I don't know why I'm having so much trouble just getting the shaders working today. I just did a similar program to this one very recently without so much trouble. Just must be a off day or something. Why am I not seeing anything coming through? The GL position is just like in normal space now. Yeah, I have a vertex array object, I'm pretty sure. Yeah. Here's our vertex array object. Here's our vertex buffer. It's all from a program that was absolutely doing textures with no problem, and I just sort of scrapped it down to the simplest scratch as I was clearing the decks for a new graphics program here, and somehow I've dropped like a key piece of the pipeline without realizing it. Because that's I don't know. I must be missing something. Like okay, size of vertex. What is that's for the stride, right? That should be right. I don't have I do have blending enabled, but I'm outputting alpha of 1 here, right? So that should be fine. And that's the only thing, that's like the only feature I have enabled, you know? That's unpleasant. I apologize. That confirms that it's not that it's getting cleared out of order or anything weird like that. It's just like this is not, it's getting called, but it's like it's not doing anything. How do I test in this situation? How do I test in this situation? Out color. Is there anything else I could do to get something, some kind of sign of life out from this shader? Gee, let's just take, I'm going to track down whatever you guys suggest because I'm a little flabbergasted at this point. Blend funk. Yeah, I don't have anything. This, I just have like, you know, the normal blend function. I'm not setting it anywhere else. And there's clear color here. They both just set it to a solid alpha. Like, I'm doing just the absolute simplest stuff. This is supposed to be the Scratch program that you just start going with. And something isn't adding up. But I don't know what. Use program. And like, okay. Another thing I could do here is, okay, I have an idea of how to track this down. Okay, here's a debugging technique. If I can't figure out what's wrong with the thing I have, what I can do is find ways of breaking it that confirm that things are working just so I can rule them out. Yeah, okay. I do have another question, which is I'm getting frames, right? Like this isn't just hanging. Okay. Whoops, didn't mean to do that. I have frames. I have frames and I have I'm gonna these are irrelevant right now, so let's just take those out. Okay. And then I'm going to pop in on remedy and double check everything that I have access to from the debugger. So that's just like a normal coordinate space quad right there, right? That should just give me the correct X and Y's for a quad on the screen. Buffer data. Vertex attributes. Offset of member P. Attribute 0. 0. Attribute 0. GL position. Let me double check and just read the shaders a little more carefully. Location 0 is my P value. That goes into GL position V underscore P01. So that should be giving me just normalized coordinate space quad. That's what it should be. Doing triangles here. All right. I'm going to just compare this to something that is working. This is so weird. I have no idea what to even check next. Like, that all looks the same. So now what? Let me think. I'm not doing anything that would render it to a different target. That's it. That's it. It's the GL viewport. Good call. How did I drop the GL viewport? That's a good question. Okay. I don't know how that happened like that, but there we go. Thank you. I feel like I always forget the GL viewport is a part of the setup. Every single time. Okay. Now let's get back the rest of the stuff that is actually supposed to be there. There's the real out color. Let's see. Okay, and I have some stuff getting dropped down here. View X form. All right, there we go. That's not bad. It's upside down, but that's very much more encouraging than the last hour has been. That we got that far with that last fix. Okay, so it's upside down, which just means my interpretation of, well, there's a couple things that could mean. Image load. Yeah, so this is probably loading it with the top being the first row. And when I submit it, it makes the first row becomes equivalent to the 0 UV coordinate. So top means 0 in UV coordinates, which is flipped from what it means in screen coordinates for the way the system works. That makes sense. Now, it's also a little off because that's not the original scale of the image. So we're getting it scaled down poorly a little bit here, right? This isn't MIP mapped. If I were to draw this, instead of using this, I were to draw it using avatar width and height, how big would it be? Yeah, now we're doing real work again. You know, all of that was just getting parameters to line up with each other, and now that's how big the original avatar is. Right, so I'm definitely like not just gonna want to squeeze it down and hope that the sampling doesn't add artifacts. It definitely will. Let's go ahead and play around with STB image resize. I'm not sure if STB image resize like does full on MIP mapping. Like I don't know if it resolves down. Well, let's just look it up. STB image resize. I'll pull this up over here. So read through it a bit, see what it says. No SIMD thread, so it be easily outperformed by libs that use those. Only scaling and translation support, no rotations or shears. Easy API down samples, up samples. Okay. CC++ file. This file to this resub. Full API. Memory allocation resize function is optimization from default filters. Progress max. All right. Let's go drop this in. Thank you. Image resize implementation. Whoops, I didn't mean to do that. Okay. Okay. Now let's see if we can apply this resize. What in width, in height, out pixels, turn off virtual white space while we STB headers are nicely laid out in ways that the virtual white space doesn't work with. Image resize uint, input pixels, in width, in height, 0, out pixels, out width, out height, number of channels. I'm not sure why it's like all spaced out like that, though. Anyway, input stride in bytes. Gotcha. You can just ignore that. So in this one, I have to pre-allocate the buffer, I suppose, for the output pixels. So that's easy enough. Scratch Arena. Avatar display size. Avatar display radius. Okay. If I do it this way, I won't actually want avatar width and height, but I'm going to keep them around just for some experiments that I'm going to do right now, but we'll probably get rid of them later. So let's see here. The final size is going to be that squared. So there's our avatar buff. Program without virtual white space. And it's back on. Okay. So now we call the resize function. stbir resize uint8 input pixels avatar buff raw width, raw height. I don't like it when I do that. I gotta put raw on the same side of each identifier. It's either an adjective at the end or it's an adjective at the beginning. I don't care which, but it's gotta be the same for the entire block. Because later I might decide to rename them and I want them all to get renamed using the same pattern. Okay. Input stride in bytes 0. And then avatar buff here. We're just gonna tell it do it like this. Now this only really works if these are already squares, right? So what I might need to do is also have a thing that's like, if it's not a square, trim it down to a square first. I want them to be squares with the way I'm going to use them for now anyway. So the way I'm going to process an avatar is load the raw one. If they're not squares, we'll add it to do. If it's not a square, make it into a square first. And that'll just be automatically like take the center, clip the top and the bottom, or clip the left and right hand side, whatever needs to be done. And if that doesn't make a good result, I just go and modify the image to be centered on the right thing and make it a square myself and save that in the data folder instead. Width and height then are the same. So when I resize, I'm scaling the width and height an equal amount. And output stride. And then the number of channels here is 3. So that's the number of bytes, but I also need to multiply it by the number of, okay. By the number of channels. Okay. Avatar buff. Avatar buff. Identify parentheses. Okay, comma. Okay, so we don't need the width and height. These are just going to be avatar display side now. And those can be raw width, or width raw and height raw. Okay. That's one remedy can help with. Let me just double check here. Okay, boom. All right. So what's happening? Oh, I'm freeing the wrong buffer because, yeah. Makes sense. All right, so I don't know if it's possible to really see the difference. It might be kind of too small. I'm gonna probably be able to do this at about that size. Maybe I want it bigger anyway. Let's start with making it a little bigger. That's what it looks like. And then let's like switch it back and forth. Rescaled equals 1. So if it's going to be rescaled, then we do, yeah, that's what I'll do. Width, height. If rescaled, otherwise, avatar buff equals avatar buff raw, width and height equal width and height raw. So we just grab the unscaled version if we're not rescaling it. Either way, that flows down to here. And by the way, I don't have to worry about the memory manager on this since it's on an arena. That's why I'm only freeing the one that comes back from STBI. Yep. And then down here, if it's rescaled, we just use the display size that I actually want. And if it's not rescaled, well, no, I'm gonna have it draw it the same size either way. And we can just see real quick if it does in fact look better. That's not it. This. So there we go. And then there's it's subtle, but I feel like you can kind of tell. It might be hard for you guys to see, but I can definitely see that it looks funny when I do no rescaling. Here, it definitely has like that like weird like around my nose, for instance, here. I don't know if you can see it, but like it looks pixely. And then if I do this, does it still look that way? No, it does look a lot more smoothed out and correct this way. So I think that's doing what I want it to do. So that's a good first step. We'll commit to doing things rescaled. Through STBI image. That's a good step one. Let's see, I'm gonna catch up with chat real quick. Okay, nothing here. Okay. So let me get my head around a couple of the things I want to do next. I want to yeah, I have a couple of things to do. Maybe we'll make a to-do list here. Not those to-dos. Those are for other versions of myself to work on. Today, I wanted to do just for this project. Something I needed to work on is support arbitrary number of input avatars with automatic layout and avatar processing. I want to create more detailed geometry for avatar. Obviously, we at some point need to do the audio processing and then apply visual effects based on audio analysis. Input audio tracks. I feel like this should probably go here. Okay, so let's, because I don't want to start doing a bunch of like visual stuff when I don't actually have the seed data for the effects that I really want to do. The seed data is only available after I've done audio processing. So we really need to get to the point where we have an input audio track to do visual effects. Now that gives me basically one or two branches that I should go down next. I could do expansion to multiple avatars and automatically laying those out. Just to get the avatar part fully sort of like baked in first, and then do input audio tracks. Or I could do one, like a single audio track, single avatar, and then build out the rest later. But I think even that would be wrong, because actually I don't really care about the effects that are possible with just one track. The whole point is to explore some ideas with multiple tracks. So I think the right thing to do is to just go wide first. I want to get multiple streams here of like input audio paired up with avatars. So let's go ahead and expand the avatar input a little bit. Let's see. I'm gonna have to, I don't think I need that anymore. That's how I handle one avatar. I want to split this out. Right now it's only happening during OpenGL setup state thing. I kind of want it to happen in its own block right here. That way it has access to the full context of like the input parameters to the program. So to do that, I'm going to need another OpenGL section. It's redundant, but it's just to make things a little easier. I'm going to need this here living in a separate function. So yeah, that'll go there. I want to scratch arena still. So there's our get scratch, and this needs to, I guess the only thing this generates now is the avatar texture. So it's going to return a texture, and this can be called process texture. It's going to take in the full path to the texture. Or let's call this process avatar. So there's my full path to the avatar. And then instead of setting a global integer avatar texture, it's just going to make one locally and return it when it's done. Let me put some other stuff in here. So load raw texture. Make sure the texture is a square. Resize texture. We don't need these anymore. Send texture data to GPU. Set up texture. I'll just keep that in there like that. It's a little bit heavy-handed, but for a program like this, it's appropriate, I think. I might just end up plopping all this right in the main path, but having the OpenGL stuff like pulled out into these like named blobs is not the worst thing. So that should just be equivalent, and it is. Also, I want to go resize this now. I think about 200 was what I liked. Can you imagine having like 4 of those? Could maybe even be a little bigger. Too big. So 250, 125. I think that's about good. And then the next issue is we want to be able to have, okay. Wait, how is this working? Avatar texture. Because this is still doing what it was doing before. So take that section out and it should stop working. Good. And then use the return down here to set avatar texture instead. And now it's working. Okay, that's good. So now the issue is I need to rearrange the data structure that the program drives itself off of. So instead of having a global avatar texture, what I should have is however many avatars there are going to be. And I guess I'll set... No. I guess what I'll do is I'll like pretend some parameters here for now. Eventually I want to get these from the command line. But that I don't think it's ready for that yet. So okay, so we're going to set up some input parameters here. For now, it's just going to be avatar paths, although it should grow. It should grow to include the other things that I want to pair with those. But for now, I should be able to just get away with looking at that one thing, and we'll expand it in a bit. Okay, so that is probably from trying to load, yeah, an avatar that didn't exist. So what I want to have is, let's clean this up a touch. And right here, we'll only continue if the avatar buff does not equal 0, right? If the raw buffer comes back as a null, then I don't want to try to resize it. I don't want to upload a texture, and I don't want to return a texture handle. And that'll give me a way down here of being able to go like, okay, give me a new texture. And let's rename this. We can call this, instead of process avatar, give this a more specific name, avatar texture, GPU texture from file path. You know, just name it what it is. Name it what it is in terms of what it does, not in terms of why you wrote it. Next, if the texture is 0, then we could like fprintf to standard error could fail to load equals false. And then, yeah, before we exit, if failed to load asset. Input data. If failed to load, we'll pull this out to initialize OpenGL, then we can process avatars. So we'll set this up here. Could not load avatar %s avatar paths I, and then let's expand this to be like that. OS exit process 1. Okay. That should, so that didn't exit. Oh, failed to load equals true. Okay, so now I need to take a quick break to go and set up a little test avatar here. Open this. Nice. Nice. All right, checking on the chat real quick. Yeah, okay, so Young Lane is asking a question about what the idea is here. So yeah, the idea is it's for rendering out a video to accompany like a podcast, and I have separate audio for each speaker in the podcast. I have a separate audio track, right? And so we're gonna do audio visualization on each person's track and pair that visualization up with their avatar visually, and some of the effects will probably interact with the avatar directly. That's the idea. Maybe all of them. I'm not quite sure. I have a lot of ideas for effects I want to play with, but today I'm just kind of building out the the fundamentals that make this what it is, which is, a rendering for my podcast video, and we'll get into more audio visualization stuff once the requirements are done. Right, the requirements are that I get an avatar up there for each speaker, and that you can see it light up whenever they're talking. And then once that's done, we have an unbounded amount of, the rest of the time for the jam can be spent on making the visualization better, a better representation of the spectrum and volume data, however we want, in whatever way makes it look cool. Yeah, we might also play with having the avatar. Let me show you what we have here, right? So right now I just have an avatar here. I'm thinking we'll have the avatars will probably be circles with maybe transparency around the edges or something, and then maybe they could be bigger too. But then also they might not be just sitting statically. They might grow and move towards the center, or overtake others and shift. They might shift around while they're getting louder and quieter and stuff. I don't know. So it'll be an audio visualizer where we do the normal spectrum analysis, but also they'll play against each other. So if I have two tracks that are both talking simultaneously, then they'll be kind of pushing against each other for screen space or something like that. And if I only have one talking, then the others will be sort of, decrease their saturation or something and shrink them away, and then the speaker will be larger, something like that. So it's a combination of an audio visualizer and the stuff that a Zoom chat does in a meeting. Maybe you could think of it that way. Okay, so I have two avatars loading successfully now. What I need to do is to generalize the path that draws an avatar a little bit. So that's this path. And for now, it's going to have very little parameterization. We're going to have a center position and a texture. Oh, and we need the window dim still too. And then all of this can be automatically done from that. So display radius, UV, alpha, that's just the basic geometry we have for now. Now the texture is a parameter, the wind dim is a parameter, and so this just becomes draw avatar, center, avatar texture 0, window dim. Nice. And now I should be able to just draw out all of my avatars. Skytrax, yeah, I could do stats or something. I think I would display it without using text or numbers. I don't want anything that you would have to read. It should just be kind of visually interesting. So if there was an indication of time, it might be along the bottom. There's a full timeline, right? Imagine that you can see along the bottom a sort of waveform shape that doesn't move around, that is the whole podcast audio, right? And there's a play cursor. Maybe what I could do is sort of show you the section of how long that person talks for during the I could color a range that's wherever the cursor is, be yeah, this range is how long this person will be talking for. That's a cool idea. Yeah, it's like YouTube timestamps, but just baked into the video with cooler effects. And that way it's there in whatever video player you are looking at. Does raise some interesting questions, Like, is that going to, that's probably going to be derived from the audio data itself and not manually programmed in. So it wouldn't have like titles that correlate with the YouTube timestamps. If there were going to be YouTube timestamps, that would have to just be a separately programmed. I'm just thinking about like if real YouTube timestamps and the ones rendered into the video would want to correlate, and if they should be automated, but I don't see how that would happen exactly. I would need like, yeah, that would take it too far out of the range of what I think is in bounds for this idea. Okay, so that will draw me 2 avatars, but they're going to be on top of each other. So now I could talk about auto layout. I think what I'll do for now is just say simplest possible thing. Let's see here. Setup avatar fixed layout. So for each avatar, we need a position. Avatar count. And then the algorithm for that is going to be, we want to look at the Y is just going to be fixed. So that's going to be, do I have window dim yet? No, so I want to do this. When frame count I should do it like right here. First frame processing. So this is where I will pick the layout because this is when I actually know the window dim for the first time. I could probably get the window dim up here after making it go full screen. But I don't know. Little bit silly because, I mean, honestly, more importantly, I'm probably going to make the layout dynamic later. So why would I make it the same every time? I'm going to just do it every frame for now. I think if I do anything else, I'm going to overthink it. And later I will know more if there's some stuff that I can pre-compute and some stuff that is every frame that is going to like be based on the pre-computed and you know. And the active like ongoing changing stuff. Okay, anyway, avatar frame, avatar layout, that's what I need to say here. The Y is just the window dim Y times 0.5. The X is going to be based on X delta is going to be window dim dot X divided by 1 plus the avatar count, right? So if I have one avatar, this becomes the window dim divided by 2. If I have 2 avatars, it spaces them out evenly from left to right, right? And then what we do is for each avatar, we set the avatar position by X delta. Here, I'm going to just make an X here, which is going to start off at X delta. X avatar position 0 dot Y is Y. X plus equals X delta. And then here, instead of giving each of these a center position, I just give them avatar position I. That's not quite right. Need to use I's here, not zeros. There we go. All right. Spooky. I like it. We're getting somewhere. So that's the basics of having multiple avatars as inputs. Obviously, I haven't really given them as inputs yet. So let me come up to my to-dos and think about what's coming next. I can process multiple avatars, lay them out. So let's go ahead and get some input audio. I think I'll take a short break from talking and programming just to hang out. If there's any questions, that would be a good time. And then resume. Youngling asks, have you done any audio viz before this? I haven't done any audio visualization, but I have already written some signal processing stuff. So I've done some audio analysis. I just haven't visualized that. I've used it to like make, a low pass filter and a high pass filter and that kind of stuff. Skytrash, yeah, this is built on top of my YouTube code base. It's not actually going to be shipped with it. So my YouTube code base, I'll give you a little tour. My YouTube code base the whole YouTube project lives in the Mr. Forth folder. So here I've got like, my video editing work and all that. Inside this folder, there's my actual code base. This is what's on Git. If you go to git.mrforth.com, this is all there. Or rather, something close to this. Obviously, this has gotten ahead of the Git again. But the podcast lives in this folder and the video renderer lives here. And it might be something that I just end up shipping later, but I want to start being able to, this is not something I've done a lot of yet, but I want to start being able to write small programs that are separate from the code base so that I can, I get into situations where I want to work on a side project built on top of my stuff, but I don't want to derail the current YouTube series. I have 5 commits on the Git, and I usually use those in conjunction with the YouTube videos to keep track of what I'm doing in the YouTube series. So the core code base can't also contain these side projects, or else they get interleaved and messy. So what I'm trying this time is putting it here. What that means is it's not in the main Git branch anymore. It's like a separate code base built on like a satellite code base to the other one. And I might integrate it or I might just keep it separate. And obviously another advantage to this is sooner or later I'm going to build some non-open source stuff that's going to go on top of my code base. I am not doing it yet, but sooner or later I will, and that I will also want this. So I'm kind of practicing with this satellite code base idea right now. But besides that little hitch, yes, it's on the YouTube code base. Okay, so before I can make any more progress, I need some audio. And I think it'd be most interesting if you guys could hear the audio while I'm working on it. So I'm going to turn on desktop audio just to make sure you can hear. And then I need a non-spoiler audio sample. And I need 2 tracks. So this next bit might get a little awkward if you're here live watching this happen. But once it's done, I promise we won't have to do it again. All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of 2 people talking to each other, but there's only the 2 of us in the room, so it's got to be you and me. Yeah, hi, normal Alan. This is going to be super awkward because I'm literally just a person talking to myself, and in a minute, it's going to get even weirder because I'm going to have to go in back and figure out what each part of it is, but I think it should be fun. Yeah, I think so too. I'm a little worried that the people listening are going to find it uncomfortable while we're doing it, but it's not going to take too long. We just need like 60 to 90 seconds of this. Yeah, totally. So tell me, why on earth didn't you just prepare this ahead of time so you don't have to do it live? Well, I thought about doing that. I really did. But the thing is that I just didn't get around to it. I have the real podcast, which I was editing up until about an hour before the stream. And then obviously I had to go get lunch, as you know. Yeah, I do. So anyways, I think that we've got what we need. Hopefully we can split this up into 2 tracks and use it. See you later. All right, that's done. All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of 2 people talking. Do you guys hear that? When I play it from my desktop, can you hear it? That'd be you and me. Yeah, hi, normal Alan. This is going to be super awkward because I'm literally just a person talking to myself, and in a minute, it's going to get even... Okay, so next we need to figure out where the splits are to make this into 2 tracks. Yeah, so that's one of them. Every time I split it, that's just got to go to the second track. And in a minute, it's going to get even weirder because I'm going to have to go in back and figure out what each part of it is, but I think it should be fun. Yeah. Okay, so that's a split. Boom. Yeah, I think so too. I'm a little worried that the people listening are going to find it uncomfortable while we're doing it. But it's not going to take too long. We just need like 60 to 90 seconds of this. Yeah. So that's one. If I was a good editor, one thing I would do is get rid of the extra breathing in between these things too. Right? I would do stuff like that. Yeah, totally. So let's get that. We'll have them talk over each other there. So tell me, why on earth didn't you just prepare this ahead of time so you don't have to do it live? Well, I thought about... Man. Well, I thought about doing that. I really did. But the thing is that I just didn't get around to it. I have the real podcast, which I was editing up until about an hour before the stream. And then, obviously, I had to go get lunch, as you know. Yeah, I do. So anyways, I think that we've got what we need. Hopefully we can split this up into 2 tracks and use it. See you later. All right. And have a nice little fade out right there at the end. There we go. Okay, so here's Anti-Alan. We just need a new track. How do I get it? Yeah, add a new stereo track. And we're going to slide these over like this. Okay, so that's almost done, but I do want to have them talk over each other at one point. So right here where they're going back and forth, I have them go like that and see if we can kind of make a way to detect the overlap there and play with how that sounds coming out, or how that looks coming out. Maybe I will add in a little bit better, like if I'm actually, yeah, hi, normal Alan. So if I'm actually making a podcast, I'll put a little space. Yeah, I'll put a little space between people talking. So like I want to do that too. Or I put a little space between people talking when it works, like when it is not important that they're overlapping each other. So I gotta, sometimes it's, no, not like that. Undo, redo. Yeah, we want this section here to come over a little bit. Fun. Yeah, I think so too. I'm a little bit more. Fun. Yeah, I think so too. I'm a little worried that the people listening are to this. Yeah, totally. So tell me, why on earth didn't you just prepare this ahead of time so you... But it's not going to take too long. We just need like 60 to 90 seconds of this. Yeah, totally. So tell me, why on earth didn't you just prepare this ahead of time so you don't have to do it live? Well, yeah, that could be a break right there. And then to go get lunch, as you know. Yeah, I do. Okay, there we go. Let's see here. I'm gonna pop open a side window here so I can set the folder up for this. I guess you guys saw the tour. I sometimes try to like magically pretend like there aren't other folders. I don't know why I do that. It just felt like more professional to not show the guts. But here on this informal live stream, you guys have already seen the tour of the parent Mr. Forth folder. So screw it. Wait, no, but there are spoilers. That's the thing. There are spoilers for the podcast. I'm going to make you work for it if you want the spoilers. Okay. Test. Anti-Allen. Okay. There we go. File. Let's save this into anti-Allen. There we go. Good. And now I need to export one track at a time. So solo, file, export, and we're going to export it as a WAV so that it'll be easier to load. Is there an STB like MP3? I don't think there is. Like if I look through the STB libraries, there's not like an MP3 or audio. There's a Vorbis. Does that do it? What does this comment mean? Seeking implementation sponsored by blah, 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 blah. Oh, I guess these folks are willing to pay if you do more implementation work. This looks like it might not be like what I want. I mean, I'd have to render Vorbis, which I could probably do. I'll just render WAVs for now. Yeah, I'll just... you know what? You guys have a good point. I didn't see that until just now, but I should probably modulate anti-Allen a little bit, right? So we can see a difference. Let's do that real quick. I'm going to take all of this. Effect. Do I want to change the speed a little bit? I'll make anti-Allen talk just like that. Affecting both tempo and pitch. Yeah. Gotta be you and me.
Yeah, hi, normal Alan. This is going to be super awkward because I'm literally just a
Perfect.
person talking to myself, and in a minute, it's going to get even weirder because
Oh, I love it. Okay, let me re-edit this before we export. So this guy goes
like
here.
60 to 90 seconds of this. Like 60 to 90 seconds of this.
yeah, totally. So
These guys talk over each other. Little gap. Little gap. Okay. Okay, now, solo this. Let's just export these as WAVs so that there's nothing complicated to do. This will be the Allen track. And then solo this one. Export as WAV. And this will be the anti-Allen track. Okay. So, looking right here, I don't see them. What happened? Did I put them in the wrong spot? Might have just dropped them into some other random folder here. Okay, where did those go? File, export as WAV. Oh, okay, they went into my voice folder. Makes sense. Where are you? Allen, anti-Allen. There they are. Put this into the podcast for testing. There we go. So there's our test tracks. And I'm going to just go add those to the parameters. So now I'm going to start doing this. So we're going to call these speakers now. And each speaker is going to get full path audio track, full path avatar, so here are our speakers. We have Allen, and then anti-Allen test. There we go. There's our speakers. I need to go do that config now. Track path. Yeah, so our track path is this guy right here. Ba-ba-da. Track path. Is that just gotta just make that build again? Speakers. We'll call this speaker count now. At speaker count. Avatar textures. Speaker count. Speakers I dot full. Yeah, let's call this avatar path. I'll rename that full path avatar. So avatar path audio track audio path. How about that? Avatar path speakers I dot avatar path. Speaker count, speaker count, speaker count, speaker count. Okay. Okay, audio path, avatar. Oh, I got those flipped. Avatar path first and then audio path. Okay, so there's our avatars. And now let me see here. I do have my own code base has some wave loading stuff already in it. So we're gonna see if that stuff can just get plugged in and get working. I need to include wave parser. Let me go back to my main wave. Yeah, here's we go. Here's our wave includes. So, we building? Yes, we're building. Now, let me take a look at wave parser. That'll be the one that has I do not know what that this comment is missing something. But I don't need that right now. Okay. Okay, so what we're going to do, we're going to focus on what we can do with audio for a little bit. I need my video render again. And I need I do have something that might be able to help a little bit. Play temp wave. Did that use? No, it didn't. Okay, that's too bad. Yeah, I'll just have to figure out a little bit about how that works again. Should I use? I guess I should use floats. Okay. 2 channels. Sample count. Yeah, that should be good. Put audio. Okay, so for this part, I want to look at each of my speakers. Each speaker has a path, so we're going to get a string 8 version of that. Do I have like straight from C string, for instance, or a straight C string? There we go. Straight C string speakers I dot audio path. Then I should be able to use the OS layer to load a file, to read a file. Yes. So here's my data, OS file read. Let's see, we have the arena and the path. Let's stop that far in on Remedy and just see if we got that part working. You need a cast here because my C string apparently uses U8 as the type. Very good. I think we're done with this. Remedy. I'm done with you. Let's take a look. The path is can I see the whole thing? Yep, Allen wave. Then if I load data, what do I get? I get, okay, yeah, okay, this should be good. That looks like what I would expect. Let's go a little farther. So the wave parser wants to give a wave subchunk list. So I just give it the data and it gives me the chunk list. And then I need the format data. Wait, first I need to find the right subchunk node, don't I? Wave chunk from ID. You want the subchunks. Call this the format chunk. And what's the ID for a format chunk? I guess that'll be living over here in riff format, maybe? No. Wave format. Yeah, so I want a format chunk. And I want a data chunk. Ooh, Robot J asks a good question. Do you have anything planned for the left-right channel data? So you could unbalance the audio slightly and move the avatar images to the corresponding side of the screen. Yeah, I could totally lay it out in like 3D. The issue I guess I have with that is I don't want to... I don't want to modify the audio using the video processing program. So the goal of this program, the goal of this program is that we have like an array of these structs that are like avatar audio, and I want to put that in, and I want to have come out a video, right? And if I do what you're suggesting, I would actually have to have, this would be like the graphical video, right? So maybe I could say graphics or animation, right? If I do what you're saying, I also have to output another audio, right? I have to do something like this. So like a more theoretical way of writing this same idea would be like this for those of you who like your algebraic data type notation. So this would be if I was going to modify the audio. The problem I have with that is that since it's a podcast, the audio editing I want to kind of craft intentionally, and if I ran it through this and then the audio got modified and then I published that audio, it would take a little bit of the audio quality out of the hands of the editing phase and put it into the hands of this. And I don't want to have that burden. Like if the video is a little screwed up, it really doesn't matter. But if the audio is screwed up, that's like the final product when I go and put it on, non-video platforms. That's baked in there. That's the core thing. And I'm kind of just trying to have fun and do something kind of lightweight. I don't want to take it too seriously, which means I don't want to have to think carefully about how I'm modifying audio in this process. Hopefully that makes sense. So I think I'm not going to modify the audio. However, it's a good question. Do I plan to do anything with the left and right channels? I'm not exactly sure yet. Not sure. I'm open to ideas. I'm just open to ideas that don't force me to, like, I want the audio that I create in the audio editor to be the final audio. So as long as that stays true, I'm open to ideas that involve how to use the left and right channel in the animation. But yeah, so I'm also not sure like how I might actually mix them down to a mono channel for audio processing for the purpose of audio visualization. I'm open to suggestions. I've never written an audio visualizer before, so for the audio visualizer part of it, if there are cool ways to use left and right channel, I'm open to I'm all ears for it. My gut instinct is that I actually just want to mix them down into one, so that I don't have to think about like how to apply an effect when on one channel it's a little bit of a different parameter than it is on the other channel. I haven't gotten ideas of how I'd actually do that. Anyway, let's take a look in Remedy if we get all of the chunks we need. Looks like we got our chunks. Nice. So next I want to grab wave format data, and I do that by going wave format data from format chunk. So I give it the format chunk and the original data, and it gives me the format data. So now I know stuff like how many channels there are, bytes per block, blocks per second. Yeah, I renamed stuff a little bit here. Bytes stride per sample. Bits per sample. What did I mean by block? I think I meant a block as in a sample times. I think I meant a sample for each channel, right? So I think a block would be like if it's 2 channels, then there are 2 samples in a block. Byte stride per sample. How would that be different from bytes per block? What was I thinking? I can't remember what this naming scheme means anymore. Bytes per second equals bytes per block times blocks per second. Valid bits per sample, bits per sample. Bytes per second is almost certainly how many bytes in the buffer the cursor has to consume in a second, which means blocks per second is probably like samples per second per channel. Or yeah, samples per second. With the number blocks times bytes per block would mean, okay, so if I have a wave file with 2 bytes per sample, for instance, we got 16-bit audio, and that's 2 bytes per sample, but there's 2 channels, then that's 4 bytes per block. I'm pretty sure that's what it means, right? So one sample is one number in one channel, but with 2 channels, I want to know, since I don't know how many channels there are, that's a variable. A block is the quantity, like the object. It is a slice of one sample for each channel at the same offset inside that channel. So if my interpretation is correct, then I'm trying to remember what these other things, what is channel mask, for instance? Channel mask. I think these were things that were like, and that's not important. Bits per sample is how many are actually there. So if it's like, if it's 12 bits or 20 bits or something, you know that it's going to say more bytes per sample than are actually valid bits per sample. So you want to know how, like, if it's 20 bits per sample, for instance, then you don't want to treat 2 to the 32 as the maximum value. You want to treat 2 to the 20 as the maximum value, even though it's still going to use 32 bits probably for each sample or something like that. Or it might just use 24, but anyway. Yeah, I think I get how that works. Format tag. Do I have that living around here somewhere? Right, so this tells me, yeah, hopefully this isn't anything weird. So let's take a look. This is where it'll actually be most interesting to just say, let's take a look at what I've got, because I'm going to kind of like, I'm not going to try to make this flexible enough to handle any possible input. I'm going to make it just handle the inputs that I have, since I'm using it to render my podcast, which I know I'm under control. The audio is under my control anyways, so I just kind of need to see what I'm dealing with here, and then I can extend it in the future if I really need to treat a different kind of input audio. Okay, yeah, that's what I expected. 2 channels, bytes per block is 4. Bytes stride per sample. So that is telling me what a single sample byte stride is. Bits per sample, 16. Okay, yeah, this all makes sense. So I have a 16-bit audio file here with 2 channels. That's leading to a 2 bytes per sample stride and a 4 bytes per block stride, right? Because this is basically this times this is this, assuming that there's no padding or anything, right? Blocks per second is our the sampling frequency, essentially. Yep, okay. So what I'm going to do, wait, hold on. Let's actually just, can I copy this? Ugh, it didn't work. Bytes per block, bytes per block. Bytes stride per sample. Bits per sample. 16. Okay. Thank you, Remedy. So I'm going to just say we've only supported this particular layout for now. There's some easy things I could do, like if it's mono, just, you know, treat the one channel as both channels. If it's a different frequency here, probably resample it. Okay, so both of our audio files do in fact match that. So all right, so now what I can do is I can use the data here by going, okay, first of all, you're going to need a cast at the end, but it's the data string plus the data chunk offset, and then the sample count tells us how long this particular track is. Sample count, that's going to be the data chunk size. Let me go make sure I remember this correctly. Offset size, yep. That's going to be the size divided by the number of bytes per block. Okay. Block count, actually. And then what I want to do is I'm going to convert that into a track. Almost there now. Track equals, let's make these plurals. Arena track speaker count. And then here we go. Channels. Channels, channel I equals push an array onto the arena block count. I have like buffer operation functions. But they don't have strides apparently. Oh yeah, these need to be signed too. Yeah, these are pretty primitive. So let's just piece them together the way that they already work, I guess. So bop on interleave. Here's the arena. I'm probably going to just start throwing all of this into a scratch. In fact, begin ems get scratch. I have an arena, so I should probably do that just in case. It's sort of like it's already known that this particular code path does in fact mix temporary and permanent allocations. But let's see, when we load the file, that can be temporary. When we split the file into sections, that can be temporary. When we uninterleave the data, that can be temporary. Okay, uninterleave, so the input data comes from here. I guess we could just simplify down. There are 2 lanes. The element size is 2, and the element count is block count. So this is format channel count. This is format bytes stride per sample. That's an element size, lane count, block count. That'll give me 1 string for each lane. Format channel count. And then I want to do F32 sample data, bop F32 from S16, which I don't actually already have, so we'll go do that. Output arena, split sample data, channel I. Take a look at those. But first, let's go implement this. I'm not going to put it in the core code base, so it's just going to come up here. F32 from S16. Element count. Allocate output. Fill loop. Inputter S16, S16, outputter F32, out, F32, OPL putter, good, inputter, outputter, read S16, multiply to F32. Let's see, how do we want this to work? If x is greater than or equal to 0, then f of x is the F32 of x divided by max the F32 of OX7FFF else 8,000. Right, something like that. So if this is less than, it's a signed integer. If it's less than 0, we divide it by the maximum negative value, but we treat that as positive because that's already negative, so that should give us a negative, I think. Yeah, that seems right. That seems right. Right. F32, outputter equals fx, package, output buffer. I don't love some of the style decisions in this old code. It's interesting to look at it again and think about what I would do different if I had another pass over these buffer operation things. Plural. No, I don't ampersand in this code base. Plural. Okay. So I should be able to get far enough in here. To see this. F32 sample data. How does that look? Well, it looks, I mean, it's like unintelligible because it's been casted to bytes. Let's look inside here. So it comes in here, and when it's done, we have like that as an array. Is it weird if it's not like perfectly 0 at the beginning there? I mean, it could be that that's fine if it's just like this was just the background noise and I didn't see enough samples to get to the perfect zeros. There's definitely spots where it's totally silent, right? So like sooner or later I should be seeing that, but yeah. Okay. Yeah, okay. I mean, I don't know why it's not like absolute 0, but it's pretty close. It kind of works, I guess. Let me just double check this a little bit more. Okay, so the first one here is the left channel of the Allen audio. So I'm talking right away, and it isn't perfectly silent. But let's take a look at those pointers there. First of all, what is L count? We have like 3 million samples. Okay. Inputter, L count. And so it's got a little bit of noise. Here, more noise. That's the first 1,000 samples, which hardly even gets you very far into the audio. Out of 3 million, you know, it takes 44,000 just to get 1 second in. So let's look at that. Let's look at 1 second in. So there's me actually talking, right? Those are bigger numbers. And if I keep going, there should eventually be a spot where in Audacity, I had a completely silent run because there was not, it was like an empty section in the track. more of me talking. 4 seconds. 5 seconds. 6 seconds. 7 seconds. So you don't think it would produce true zero even at the silent bits where there's no audio? Would it like just produce I mean, it should definitely get close enough to zero that it doesn't look like noise. Hold on a sec. Right? Like, this indicates noise, which should not be happening the entire time. Let me double check something here. I can just correlate this. Okay, so the first silence should begin by second number 13, right? There's nothing here. So what does it look like when there's nothing there? Yeah, okay, so it still renders out with like these little wiggles. I find that kind of strange. I don't know why it would do that. Yeah, I figured that maybe we weren't on the same page there. I'm looking at the signed samples coming straight from the audio. So here in Audacity, I have this track, right? Looking at this track here. And there's no audio at all in this chunk. And earlier I was looking at this chunk, so I knew that at second 0 it should be empty. But the signed input integers weren't even giving me perfect zeros, like for this chunk, which I guess is just what Audacity is doing. Like even when it's perfectly silent, it's generating like all minuscule white noise. I'm not sure why exactly it would be doing that, but I mean, it's not that surprising either. Audio stuff is a little bit like that, I guess. I don't know. It seems strange though. Like why that, how is, yeah, so if I go over here, let me make a new one. Just give me a blank Audacity so I'm not like tied to that project. Okay, file, open. Here's that channel by itself. And you see, like, this is the silence I'm talking about, but for whatever reason, when it rendered out the silence, it put in just minuscule white noise here. But that's fine. It's not really a problem. It's just I was trying to verify that this like makes sense. So given that the inputs, so just so you know, if these were perfect zeros, then I should be getting perfect zeros in the floats, because floating point weirdness is not like completely random and arbitrary. A 0 in the numerator here would always create a 0 float. But since they're not perfect zeros anyway, yeah, I get like, I get this thing where it's like 0 and then garbage, garbage, garbage. It's like just barely different from 0 and then 0, 0, blah, 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 blah. But that's just because the input numbers weren't exactly 0 in the numerator, so I did get these minuscule little things. Okay, so I've got my channels converted to floats. Oops, no. This is the buffer up, so I don't want to change this one. So over here, write F32. Yeah, okay. So there we go. I've got that. And so then what I want to do is say channels, channel I dot, or equals, cast it to a floating point, F32 sample data dot stir. Okay. So there we go. That gives me my two channels, and then I can set the track like this. Track I dot channel. Well, I guess I don't really need this, right? This is more like track. Let's just fill the track in. I want to separate it out. Track I channel 0 equals channel 0. Channels 1 is channels 1. Track I dot sample count is block count. Yeah, so the thing with floating points is they are, they do behave erratically in some senses, but you don't want to treat them like a magical, uncontainable problem. They are understandable. They do behave in predictable ways, just predictable with more effort than integers or continuous variables in mathematics behave a little more cleanly than floats. Obviously, they don't have rounding errors and stuff. But there are things like, okay, floating points always land on perfectly binary numbers still. So you can't exactly represent 1/3, but you can exactly represent 10 or 1/2, because those can be represented in binary, right? But 1/3 requires an infinite repeating binary representation, right? It's like, what would it be? It would be can't be 0.1 repeating, but like 0.10. Yeah, it'd be 0.1010101010. That would be 1/3, and so that can't be precisely represented. Yeah. If you've ever done game dev stuff and had like collisions be weird, then you just get burned by floating point and always assume the worst. But they're not like random, They're just, you got to know the weird tricks if you want to be able to predict them, which takes a lot of work to learn. But 0 behaves like 0. That's one thing you can count on. There's also -0, which is weird. I mean, it's still weird, but yeah, 0 divided by something should always be 0. Alrighty, so I filled out my track structs. Now we need to start making decisions about, like, this is just extraction. But what I really need to do is figure out how I want to process a track. So, yeah, what we need to do. Yes, Terry is Python. Yes, they are deterministic. That is true. There's no randomness involved. They are deterministic, but there are some other weird things. Like if you rearrange an order of operations, which algebraically is equivalent, that's not guaranteed to give you the same value. Like if I have, x times a plus b, algebraically, x times a plus b equals x times a plus x times b. This formula works for real numbers, right? For real numbers, and for like. What's the other one? What's the rational numbers, right? Like well-defined mathematical style numbers, this works. But in floating point, this doesn't necessarily work, right? If you do something like, oh, this would be slower than this, so you rearrange it, you might get a different result. So it's deterministic in the order of operations you do, but it's not deterministic algebraically, if that makes sense. It's calling that non-determinism is wrong, but you get what I mean. It's like you can't apply your usual algebraic transformations, that they don't actually hold. They hold up to some amount of error, obviously, which means depending on how much error you can tolerate, you can or cannot apply them as optimizations, which is tricky for compilers. Anyway, Yeah, so what I need to do is take a minute and think about how I want to structure the experiments with the audio processing part. So, for instance, suppose I decide I want to mix these tracks down. I think I'm going to just leave the track like this so that the input is represented correctly. And this means I'm going to use too much memory, but again, this is a sort of throwaway program. It just needs to use up all of the resources that I want in order to render the video correctly, and then I'm done. So the next step here is let's try to just wiggle something on the screen. Let's make something happen to demonstrate a little bit of animation. Maybe that'll get me thinking. The other thing I could do is start trying to set up the audio processing by like saying, let's assume I do want to mix two channels down into one. Let's say I'm going to throw away left and right as a first move. And if you have any ideas on how I could use left and right in a clever way, let me know. But I think maybe I just throw them away because it's not like I have any intention to actually have panning here. So the stereos are only different because of if anyone had a mic that caught something slightly different on the left and right hand side or whatever, it would be captured in there. But like, I don't really need stereo for any reason. In fact, it might make more sense to ship podcasts in mono. I'm not sure. I mean, I could intentionally edit it to pan one speaker to a different position than another. And then maybe I would want to be able to apply that into the layout of the speakers or something. But I hadn't really thought about all that. So for now, I'm going to just mix it down into one channel and then do a wiggly, useless animation on top of that just to start experimenting with what it'll look like when I'm processing the track and gathering more data about it. So yeah, let's say we have processed track, and that will be like this. Step one, we make a mixed version. Why would I do this though? You know, I think I'm doing something a little bit wrong from what I actually want to do. I don't want an array of tracks. What I want is an array of processed tracks. Or something like that. Arena process track speaker count. Because it's not like I have an array of texture buffers. I have an array of GLU ints, right? So track really just exists to give me the extracted version here. So why don't we pull that out first? Just like we have GPU texture from file path. I'm going to start throwing things in here. We get track from file path, right? Track channels. Yeah, okay. So I want like that thought process there to become char star full path. Full path. Scratch can come out and live right here. I guess I still need a scratch there, but I also want a scratch here. Because I'm gonna need to pass in an arena for this. Yep, this is making sense. And so that's a scratch, full path, scratch, blah, blah, blah. But then finally track result is going to look like this. So the final rearranged samples will come out right there. And then we can pull this out like this. Whoops. Well, hold on. I want to do it like this. Blah. Channels. Block count equals. Block count equals 0. So here, parse wave file if data.strt is not equal. So if we got some data from the file, we go ahead and do some parsing work. Release the scratch at the end. We fill the result. There we go. arena. This still needs a U8 cast here. Needs a result. And then this can just become a first step. So track equals, and we'll grab a scratch at the beginning here, but we're actually going to end temp at each step. Did I have like an alias for that for this use? No, I didn't. Okay, that's fine. So that's just telling it I don't need to carry any of the scratch stuff in between iterations, so that this can be kind of piggy on the scratch, and I don't have to think about it too much. So now, what was the name of the function we just wrote? Track from file path speakers I dot audio path. Okay, so we grab the audio path, throw it into a track, and then the first thing I want to do, I'm going to be making a processed track. So the first step is going to be to mix those together. Arena into the scratch arena. Let's see, scratch arena. F32 track sample count. Track.sample count. 32 sample count. Track.sample count. Yeah, let's just do that. Okay. And then I want each mixed sample will just be track.channels 0 plus track.channels1, add it together, but then I probably want to assume that like those can each max out at a +1 or a -1 at the same time, and so to keep them from going past the max, renormalize it back by multiplying by 1/2. Hopefully that's a good way to mix them. Let's say that for testing, I want to be able to dump stuff back out. So we'll come over here to my wave parser stuff, and I also have a wave render function right here. That way I can listen to the result. Wave render. System. Okay. Let's grab those wave render params. Okay, that's an awesome question. Rizoma asks or says, I'm still confused sometimes on when to extract code to functions when there's no need for that code to be used more than once. It seems that maybe one can extract code when its implementation does not produce any side effects in the color code path or something like that. So yes, I like what you're saying there. There's a couple trade-offs. So one thing is, I don't even think you want to go as far as to say if it needs to be used more than once, it should be extracted into a separate function. Sometimes that's the right thing to do, but a lot of the time the right thing to do is to say, if I want to use this in 2 different places, is there any way to make those 2 different places converge into one place? So instead of saying I need a function so that I can apply this here, 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 and here, you say, can I make all of those paths into one loop in one spot? Right? Can I make it so that the control flow gets all of those cases going through at the same time? That's even better. But if you can't do that, pulling it out into a function for reuse as like a library format or something like that is good. So the second thing you said there is also awesome. I like that thought process. I tend to think about it like, is this a natural data in, data out block? Can I take this block and treat it very simply as data in, data out? And if that block requires like 20 parameters, then maybe that's a bad block to pull out. Maybe I can go up a little bit farther in the chain or a little bit lower in the chain and find a block that takes only 3 parameters or 5 parameters and pull that out instead. So on the flip side, if it produces like 10 results, that's hard to pull out into a function. But sometimes you don't have any control over that. Sometimes you really need to pull something out into a function that takes too many parameters or returns too much stuff. But if you're only using code in one place and you're thinking, well, it might make it look prettier, the question is it a simple data in, data out thing, or is it a rather complex knot? If it's a complex knot, don't pull it out, because then you're dealing with lots of parameters and lots of returns. And if you don't have to deal with that, don't. But if it's very simple data in, data out, you can pull it out without causing a problem. If you need to reuse it and you can't make the control flow avoid the duplication, then you could pull out as a function. But anytime you're pulling something out as a function with lots of parameters or lots of returns, that is like that is the negative scenario. So you want to avoid that by either picking a different factorization with less parameters and outputs, or avoiding control flow where you need to call complex knots from 2 different places. Hey, Andrew. Yeah, it's been a while. Okay, so I need to fill out the parameters block. So this is a float 32 buffer. It's got one channel, and it's got, oh, I don't have we have a hard-coded 44100 right now. Channels 0I, channels 1I. You know what, let's just do out equals mixed, in 1 equals, in 0 equals track, channel 0, in 1 equals in 1. Out plus equals 1, in 0 plus equals 1, in 1 plus equals 1, out equals in 0 plus in 1 times 0.5f. Whoops, didn't mean to run it. Okay, blocks per second. Block per second, not plural this time for some reason. Okay, so I got the test out there. I should be able to just save that now. Let's dump out test.wav, test out. And now I should have, do I have my wave? Yeah, in my project over here, I used to have a thing for running run play temp wave. Let's drop that into the current project. F5, how about? Run play temp wave. Play temp wave.cpp. Temp file. Temp HQPS. Okay. Yeah, so I just need in here wave Mr. Fourth source play temp wave temp wave.h temp wave.cpk. So we need temp wave h, temp wave cpp, and then in video render.cpp, I don't dump it to test.wav. I need to get the temp wave file name. That'll give me a place to drop that. Okay, and hopefully, if I let's see, I have to go, I'm in the video render folder. build folder. No, just video render folder. So I need to go back once to get to podcast, back again to get to the root, into the Mr. Fourth folder for the code base, and then into the build folder for the code base. Let's just wipe these out, not doing those. Reload the project. Main cpp test.exe. Run. Oh, I must be in the... Yeah. I reloaded the wrong project. Podcast video render. Load this project. Play temp wave. All right, let's take a look. Mr. Fourth, build. Play temp wave. Podcast video render. Okay. Let's just have it echo the current directory. Reload the project. What? Oh, right. Windows syntax. So like this. Load project. Mr. Fourth podcast video render. No, that's not it. Push D. Why? What am I missing here? All right, if I... Okay, one thing at a time. Load project. That should be video render. Now, if I push D ... and do this. Load project again. It doesn't change it. That's weird. If I do this, it does change it. So it is reading this. It's just not doing anything when I say push D first. Just kind of strange. What am I missing? Well, I'm missing like the easy solution. Maybe instead of telling it that, I could... Does this work if I do this? First of all? No, that doesn't work either. But it says over here in this project file that that's what I was doing and it worked. Why would it not be working here? I've got a build folder. It's not like... Spoilers. It's not like... It's not like it can't find it. Well, screw it. Let's try this a different way. Let's just CD and see if that does it. What? Oh wait, I didn't load it that time. That's fair. Nope, still not working. And this is the project I'm loading. Run, play temp wave, out, run, footer, pan, dirty, right. Okay, that's all happening. It does in fact pick that part up. It's just not picking up any of the changes in directory for some reason. Super weird. So it can do two commands. Yeah, I am reloading the project. Like, okay, look, Here we go. CD dot dot load project F5. Why did it not pick up the change in directory? Let's find out. Nope, that's not it. This works. Okay. Hold on. If I'm in this project, so this is the like normal Mr. Fourth project, not the video render one. We're in this one now, and I want to build play temp wave. That builds, and I want to run play temp wave. That runs. So it does in fact work. Run out. This is a copy paste of the same thing. Push debuild and play temp wave. And if I were to play temp wave and echo CD, what would happen? Okay, that doesn't actually, the echo CD isn't picking up. So even though it's correctly running the exe, it's not picking up the change in the executable path or the current working directory. Is it like not, is that not the, no, but that wouldn't make any sense. Let's just do this. Okay, so that is a better way to do it. Got it. Okay. Something about the echoing CD isn't showing us what we think it's showing. That's okay. Now we know. We pop back in over here, load this project, look at this project, hit F5. Nope, sorry. Try again. Load this project, hit F5. There we go. It's not doing what we want. Forget this guy. Dir instead. Load project again, F5. Okay. Spoilers. Slash dot dot Mr. Fourth build, reload the project, F5, that's the right path. And now play temp wave, F5. Oops, load project, F5. Now it's working. I don't know what went wrong the first time around, but now it's playing temp wave, but it's not actually making any sound. Which it should if it was working correctly, unless I hadn't done that yet. Okay, so let's track down what that file looks like. Yeah, I might do this over here because I don't know what might pop up while I do it. I need to go here, here. I'm not seeing anything that looks like, you know, why don't we do this? Why don't we look at the temp wave file name in Remedy real quick. File name. Remedy, you gotta be able to copy text fields. Okay. All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of 2 people talking to each other, but there's only the 2 of us in the room, so it's got to be you and me.
Okay, so yeah, the audio is there in the file, but it's not getting played by the thing that's supposed to play it.
That's this button, right? That's supposed to be playing the audio. So do I want to... I'm just going to say let's forget about playing the audio automatically. I don't know why that's busted. Let me give it one shot. Let me give it one shot to look at. That's the name of the file. Play that. Is this one of those things where it couldn't play a floating point wave file? And so if I wanted to make this work, I would have had to convert this first. I think that's what it was. I think I encountered this before. I have to get this in exactly the right format for this function to work. So I'm going to skip this. And I'll just keep the file up over here and manually play it for today. Let's look into... So that made a mono-channel version that sounded good. So that doesn't lose any of the important audio information when I mix it down like that. So that's what I needed to confirm. So now we can move on to step 2. So I've got sooner or later I want to start rendering some graphical effects. I might start with that tomorrow on the second stream here and wrap up with just doing a little bit of the audio analysis. So let me go up to my to-do on the top here. That's what I should do. Input audio tracks, check. So now let's do the audio processing. That's what needs to happen next. So if I remember correctly, I have some... filters already, but I need to use this complicated type system that I set up for it because I wasn't really too good about the API design here. So here we go. Here's the rate. Sample per second, 44100. Okay, odd-gen buffer. I don't like this. It should just let me... I guess it's so that I can... Yeah, there's reasons why it's this way. It's so that the parameterization is a little bit more natural for someone who doesn't remember how to compute it. It's hard to explain. But yeah, so let's see. I need my buff. My buff is going to be the mixed. The count is going to be the sample count. And then there's the rate. The rate, oh man, I don't love it. I just don't love some of the things happening here, but okay. So now I've got my buffer. Range T. I assume that's a number of seconds. Odd-gen, low pass in place. It doesn't even... this API is messed up. I should do another pass over the audio generation stuff someday. Someday soon. But I1F32, I want it to go from second number 0 to... I need to know what the end of the track is called. I guess... Yeah, so this doesn't, this API has some problems. I need end T, which I don't have, and cutoff frequency. Let's say I don't want anything over 200 hertz for now.
Have a good one. Thanks for coming to hang out. I'll be back on tomorrow, probably earlier, so if you want to come hang out some more, that would be cool. If not, that's cool too, but yeah, good to see you. Okay, I need to figure out the end T, which is going to be like... Yeah, it's just not built into this API at all. So it doesn't have a way for me to say, hey, I don't have seconds, I just have number of samples. What do I do? But... I need seconds. So I probably just look at what can happen on rate here. And I say, yeah, I probably just say rate dot delta t, so the number, the amount of seconds that is elapsed between samples times my sample count probably gives me the t I need. And yeah, I got to go grab all my odd gen headers and stuff now. autogen.h, temp wave, autogen.cpp, end t, yep. Low pass in place, but that's going to modify. Does this thing, yeah, it still has a running instance. That's going to modify the whole thing in place. So what I actually have to do is make a bunch of copies of it first. So I'll call this, yeah, this can come live up here. This can be low pass 200 equals push array scratch arena F32 sample count mem copy. Wait, I have a wrapper for that. Memory copy, low pass 200, mixed, size of mix times sample count. Oh, I hate this API so much. I really did a mess here. Anyway. If that's correct, then what should happen is I should be able to low pass 200. So we're gonna dump out this dump variable instead of mix so that I can dump out whichever one I want. So let's just test what the low pass audio sounds like there. All right, I'm here talking to Anti-Alan today. That doesn't sound any different. Oh, I stopped putting low pass 200 in here. All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of 2 people talking to each other, but... All right, let's try and move that around a bit and see what happens. All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking... Does that sound like a low pass filter to you? It sounds like quiet, but not necessarily low pass. I'm not sure. I'm not sure my low pass filter works. Cutoff frequency. I don't remember this super well. next v equals alpha v equals next v putter equals v. Next v equals alpha times current value plus n alpha times v negative alpha. So this is an linear interpolation between the current sample and a v value. Then we emit the current v value and we emit the linearly interpolated value there, right? Next v. I mean, yeah, this could be written as something a little simpler. I was probably a little confused when I wrote it. All right.
All right, I'm here talking to Anti-Alan today.
So what I want to try to do is see if I can apply a band pass by chaining these together. So we'll have one that's like this. Pass 2040, 2040. So the high pass in place says anything over the 20, and then the low pass in place is anything below the 40. And then this is this is pass 2040. Okay.
All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking.
Okay, now let's see what happens as I shift up the frequencies. I should hear it get louder and quieter depending on how close it is to my the natural frequencies dominant in my voice.
I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get.
I'm not entirely confident that my bandpass filter is going to work here. So we're just kind of getting a vibe for how strong the effect would be if I try to do it this way.
All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of.
Yeah, that's a little better. Maybe it is sort of working.
All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of 2 people talking to each other, but there's only the 2 of us in the room, so it's got to be you and me.
Okay. It did like get significantly more audible there, which suggests to me that it is actually doing what it's supposed to be doing.
All right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of 2 people talking to each other, but
It's funny because it does sound like higher pitch now too. Maybe it is working. I don't know. It's not quite like it's not a pitch shift, which I guess is what I was anticipating it to sound like, but it doesn't sound like that. It just sounds like a different variant of your voice. It's like changing the color correction on a photo.
all right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get 2 tracks of 2 people talking.
Yeah. And I'm not an expert on the, you know,
All right, I'm here talking to
acoustics
Anti-Alan
involved.
today. Hey, Alan, we're mostly just talking so that we can get two tracks of two people talking to each other, but
So I can't exactly say what the correct like ranges are for human speech, although I think it's got to be not much higher than this because think about this. 100, 200, 400, 800, 1600. Yeah, if this was working, this would be really high pitched, wouldn't it? Let's go for one more.
all right, I'm here talking to Anti-Alan today. Hey, Alan, we're mostly just talking so that we can get two tracks of two people talking to each other, but there's only.
Yeah, I'm not sure. I'm not sure. So I think the only way to know if this is a useful approach or not is going to be to like build something on top of it and see how it looks. So what I think I want to do first is before I apply a bandpass filter, I probably want to tomorrow just take a single channel unfiltered and identify silence and non-silence because that's more of a prerequisite, like required thing to make this even serve its purpose okay-ish. And if I can do that, then I can and I later succeed at generating these like filtered channels, then I can pass those through the same rule. But either way, I need that rule. It kind of estimates how loud a given stream of samples is at each moment, right? So I think that is the correct next step instead of focusing on if I've got the bandpass filter right. And that way I've got the basics for at least visualizing volume between multiple tracks. I might need to dive a little deeper into the audio processing side to get this stuff just right. But at the very least, it does sound like I could kind of measure which pitches are the most present this way. I'm not sure how accurate it is right now because this should be like so high pitched that it's not right. Like I don't know. It just doesn't seem like that should be within the range of a human voice to me. Maybe I need to go do some research on that too. Oops, I might have closed my Explorer thing there. Pull that back up.
All right, I'm here talking to Anti-Alan today. Hey, Alan.
Let's do an experiment. If I were to load that same wave.
All right, I'm here talking to Anti-Alan today.
And apply, does it have, yeah, okay, let's do this. So I'm going to apply the exact same rule that I said right here. High pass 5120. Five 120. I don't know what that roll off implies. But this will mean the only things higher than 5120 stay in.
All right, I'm here talking to Anti-Alan today.
That is not as different as I thought it would be. And then if I apply a low pass filter, $10,024. 10,240, I mean.
All right, I'm here talking to Anti-Alan today.
Yeah. I mean, that is actually the effect I'm getting. So maybe I did it right. Maybe I did it right. I don't know. So I might need to do some research on what the useful ranges are to test in an approach like this. But let's see. If I go up another octave.
All right, I'm here talking to Anti-Alan today.
Did it apply? Hold on.
All right, I'm here talking to Anti-Alan today.
Let's just like ratchet it up like crazy. So let's say 100,000 and 200,000. Something easy to apply that's definitely higher. Yeah, it's a lot quieter. Low pass filter, 100,000. Boom. You're right. Oh, I didn't even think of that. Okay. You can't apply changes greater than 4418. Oh, you should probably not even go above 22050, right? That's like the highest frequency I'm even allowed to play with because of my sampling frequency being 44. My sampling frequency is 44,100, so half of that is the highest frequency that I can actually distinguish within that signal, right? So here's the highest octave range I could filter out.
All right, I'm here talking to Anti-Alan today. Hey, Alan,
And that's by comparison to
All right, I'm here talking to...
that, which is a lot louder. So what I'll need, I think this will work. I need to do some research, and I need to do some other building blocks, but I think we can do what I was expecting, probably. My reason for applying, okay, why are you applying applying filters? Does it produce more desirable values when you convert it to the frequency spectrum for visualization? So I'm not sure if you were here when I explained this, but I'm not converting to frequency spectrum. That's not the goal. I'm not doing a fast Fourier transform. I know that's like a typical way to do this, but the way I'm going to do it, because I have limited time to implement it, is I'm going to, so let's look at it this way. I could just do a very bare bones, unsophisticated audio visualizer with no analysis at all by taking this signal here and doing a pass over it just to determine relative volume of this whole signal, right? But so it'd be like, this chunk would look pretty loud, but then this would be a little bit quieter, and this would be silence, basically, right? This would be silence here, and then loud. This would be a very loud spike, and I'd figure that out and kind of create windows of how strong the visual effects should be, but they wouldn't know anything about pitch. They would just know about volume, right? So then the idea is if I can apply a bandpass filter, what I can do is use that to get myself a volume label, a volume amount at various different frequencies, right? I can say filter this out so that frequencies lower than this and higher than this aren't included in the signal. And so I won't have a frequency analysis, but I will have a version of the signal that mostly only contains frequencies within a certain range. And then I can apply my volume analysis stuff, which could be applied to any signal, to that signal, and that'll tell me about how loud signals or frequencies in that range are. And this lets you do a few things differently than how you would do it in a fast Fourier transform kind of thing, right? So if I did spectrum analysis, if I switched to if I did an FFT, then the frequencies are evenly spaced across like the range from 0 to the Nyquist frequency, half the sampling rate. And I can't do anything about that. But with this, I can tailor the frequencies that I detect to specific ranges, specific bands that I'm interested in. Another thing this lets you do is it lets you don't have to, with fast Fourier transform, the amount of what's the word I'm looking for? the amount of data out is equal to the amount of data in. So if you have a window, you pick like a chunk of audio and you say fast Fourier transform that, give me a spectrum analysis, then the number of frequencies I get is limited by how wide I make the window. So if I want a really short window so that I have a very precise idea of, like, you know, my video renders at 60 frames per second, let's say. So I have one frame, and that corresponds to a certain number of samples, and I grab that window. Well, the number of frequency levels I can get is now constrained by whatever window size I'm picking. With what I'm talking about doing, bandpass filters over the audio stream, I can modulate those separately. I can make the window very narrow for the volume analysis, if that's what makes sense, but still have tons and tons of frequencies. So that's why I'm doing it that way. One, I've already got the bandpass filter implemented, as we were just testing. Two, it lets me kind of separate out the spectrum from the window problem that you get with FFTs. And three, I don't want to implement FFT. The fast Fourier transform would be kind of like a whole project on its own. I haven't implemented one of those before. I'm sure I could do it, but I don't want to try to do it in the middle of a jam where I'd rather be focusing on making the visualization. So I'm going to use an unusual, perhaps, approach from what you've seen before. This is also how libquincy works. I don't know if you've seen it, but libquincy does something more along these lines, which is what I actually wanted to just use libquincy rather than doing it myself because I don't trust my skills quite as much. But since libquincy, the source code for it's not out, I'm just kind of approximating what I think it's probably doing. Yeah, it's a cool alternative way of doing things from the fast Fourier transform. The fast Fourier transform obviously has benefits over this. Is not like this requires processing the entire signal in multiple times, and then there's like algorithms for optimizing the way you process it. You look up like filter banks if you want to see smart ways of doing what I'm doing. I'm kind of doing it'd be like, you know how with a fast Fourier transform, there's also the discrete Fourier transform that's like the slow algorithm for the same thing. I'm doing the slow algorithm of a filter bank, essentially. And again, not an expert in any of this, so just approximating it according to my best understanding, given like a couple of days of research ahead of time. But I need to do more research. I can already tell that there are things I don't know. I want to know like specifically what are the ranges for human voice that I should test, because I can focus in on those rather than saying giving me the entire range of frequencies. I'll focus in on human voice, so we can get a little bit more precise that way. With like what bands we test. Xena64, I don't know what constant Q is. As I was just saying to Young Lane, I don't know this stuff super well. Maybe I am talking about constant Q. I don't know. Anyway, this has been awesome. I think this is where I want to take a break for, like, I'm going to sign off for today. I will stream at least 4 more hours for the next 2 days, possibly more since it'll be weekend days. But yeah, I'm tired of talking. I've done about as much programming as I can handle in one session. So thanks for coming to hang out, everybody. We'll get a little bit more into making the animations next time, and then maybe start doing this bandpass filtering more carefully and build out some of that. I also want to play with some of the other ideas we talked about. I need to be able to tell, when 2 tracks are competing with each other, I want to be able to tell that and have it shown in interesting ways. And I like the idea of like global things that mix all of the tracks together and show stuff across the whole thing, like along the bottom or in the background or something. So we'll play with a couple more ideas. But yeah, this was cool. I'll see you guys next time. Bye-bye.